Hello, I'm Peter Eijgermans from Ordina, Netherlands. I work for two departments, GTech, specialized in Java, and also for GS Rhodes, that is specialized in front-end technology. And this is what I'm talking about this evening. I'm talking about front-end technology, front-end architecture, about micro frontends, the what, the why, and the how. A lot of contents. I start with what is a monolith, microservices, of course, step over to the front-end monolith, and then I step over to micro frontends, integration approaches, communication between micro frontends, and how to speed up development. Let's start. I want to integrate a little my talk with a little adventure of it was a big adventure 20 years ago already. I cycled from Holland to Nepal, and there I met a creature. So I shall integrate it in the talk. Here you see me cycling in the mountains. So that was really fun. And that was in the region of Nepal, Tibet. Okay, let's start with the monolith. Monolith is a ball of mud, they say. And what is a ball of mud? They oh my goodness. Everything, the front end and the back end is tightly coupled together in the front end and in the monolith. So that is not what we want. So we split up our applications in layers. So you will recognize this. This is the front end, the business layer, database layer. But this has also problems when you change something in one of the layers. You have to, you get a ripple effect because when you change something, you have to also change most of the time also something in the other layers. So the solution for this, we thought, we are going to make microservices. Those are verticals, they call it also. You split your application up in verticals. You're in user products, payments, shipping. So the backend, can be maintained easily in this way. And we don't have problems with the ripple effect. And you see here also that we have still here one database for all those microservices, and we recognize that the database is does make the microservice tightly coupled together. So we decided to that every microservice should have an own database. What we see here is microservices are in general small, focuses on one thing and is autonomous. Here you see an example of microservices was in 2011. That was Amazon and came with the announcement that he had more than 100 microservices in production. That's a lot of. And 3 months later, Netflix came with the announcement that it has more than 500 microservices in production with more than 2 billion of requests a day. That is enormous, but they forget something. They forget that microservices has users. What do I mean about it? They forgot that they've made a lot of microservices, but they still have a big front-end monolith, which was very not handy to maintain. Everything was tightly coupled in the front end, and we want to have the same structure as in with microservices. So what have I explained now? We started with the monolith. And there I split it up in front-end and back-end applications. And then in the third way, we choose for the microservices, but still we have a front-end monolith. Here you see the creature I met in Nepal. That was looks nice, but we were walking. I was first cycling, but in this park I was walking with two guys and two friends, and we saw this rhino, and we climbed. We have to climb in a tree because they are very dangerous. Can be very dangerous. I have a little question for you. What kind of rhino is this? A rhinoceros, a black rhino, or a white rhino, or a Javan rhino, or a great one-horned rhino? Let me see. I hope you can type it in the chat. Micro Frontends are born. Yeah, this is what we want. We want to have the same idea that we the same idea is that the Micro Frontends is looks like the microservices we've talked about. Here you see a little application. This is a microfront application, and every picture is not food, but is a restaurant with its own menus. And you can filter here on this page, and you can also seek on this page. So we have here a container using this application. This is the main entry point of the application. And this container does all the cross-cutting concerns, for example, logging and monitoring or authentication, authorization, and also routing. And we use there a shared component for this, for the browser router. And we have also two micro frontends here in this frontend. There's a search micro frontend and a browse micro frontend. Here you see when you click on a restaurant, you see that this restaurant has its own menu, and you can order something. Great, that's also, and this micro frontend contains also a router, and also at the top and a user router. And also we use here a restaurant order micro frontend. How can you slice up your application? When you have one micro frontend per page, you can use very easily hyperlinks from one page to the other page. When you have multiple micro frontends on the page, then you can the picture look like this, and it is also a good habit to that every team is specialized in one micro frontend, and also the team can also choose its own programming language in a front end. Team profile can choose for React, and the other one can the catalog team can choose for Angular, for example. Integration approaches for micro frontends. What I say, when you have one micro frontend per page, you can use hyperlink integration. Integration, I mean, with integration, I mean bundling. How do you bundle your front ends, micro front ends in the front end? And when you have multiple micro front ends per page, then you can use build time integration, server-side integration, or runtime integration. I'm going to talk about it here with the same integrations. The build time, it will say that you can that you will build your micro frontends at build time. Server-side integration means that you can that you will build your HTML fragments at server-side, and the runtime integration will say that you can build your application and aggregate your front ends at runtime. Build time integration. Build time integration, what I say, we use here, bundle integration, it is easy to use monorepos. Monorepo, that is one repo which contains all the micro frontends. And these micro frontends, we bundle that together in via one Package.json. You can use for this Angular workspaces or a lot of other, or Lerna, etc. And that's such a Package.json looks like. For this container, we have the container application, and it has 3 dependencies, and these dependencies, contains the packaged micro frontends with their own version numbers, and we package this all together at build time. Advantages of build time integration with the Monorepo: you can easily share your sharing common functionality. For example, you have you can easily make a component and import and export it around in your Monorepo and use it everywhere in your Monorepo. Consistency between the micro frontends means that you can you have everywhere in the Monorepo you have the same styling, the same formatting. So consistency is very well. Testing of the application is so easier because you load your application in your IDE locally, so you can test all those micro frontends together. And you can also maintain your application quite easily in the Monorepo, because you have, what I said already, the whole application is loaded, all the microphones is loaded via the Monorepo locally, so you can also maintain it easily. But we have also our drawback for build time integration. We have to recompile and release every single micro frontend in the Monorepo in order to release a change. So this is so we have it's good that we have split up our application in little parts, but it is it's a little negative that you have to recompile and release every single micro frontend where you might have to make a release. Going further with server-side integration. Server-side integration is that you have to bundle all your micro frontends and HTML fragments on server-side. Here you see an example of an index HTML which use page includes, which will be loaded in the server side. And at server side, I use, for example, an NGINX server, and it listens on port 88. And you also see that we in the middle you see locations. Those are the routes. Here you set your page fragments. For example, when you choose for the URL /browse or /order, then the right page fragment will be set and loaded and rendered. You see another concept of server-side integration. When you do a request, there is a container application which delegates the microservices for generating and composing their HTML fragments. For example, the browser micro frontend is running on its own server and will build and generate his HTML fragment, and the other micro frontend also. And in the middle you have the container app server, which finally will assemble all those HTML fragments together, and it will then be rendered in the browser again. Runtime integration is the third one. Here we bundle, aggregate our application in the front end at runtime. So we don't use any Package.json anymore. We can use globally two techniques for this. iframe, I'm not going to talk about it, it's a very old one. And where you can use web components. Here you see, web component. You can work with web components in. You can also choose for JavaScript, but also you can work with web components in React, in Vue, and Angular or other frameworks. And what I want to say about this is the web component is with a web component you can make a micro frontend quite easily, and the web component is in this context a technique, and a micro frontend is in this context a style of architecture. So you see here this detailed page, where you see a restaurant where you can order some foods. And I'm going to show you how you make such a web component. This web component, how do you make that very in an easy style? When you want to make a web component, you have to create a custom HTML element. And I have already made it here. I created here a micro frontend order food custom HTML element, and this is also a web component, they call it also. And this tag of this micro frontend has three properties, three input properties: the name and the image URL, the large PNG, and the menu items. And how can you spin this up, this HTML element? Here is, I show you how you can create a web component. You always start with a class, and there you give it a name. I gave it the name of my micro frontend order food, and it extends the HTML element. And with the HTML element, we can create custom HTML tags, you can say. So that is what you're going to do. We're going to make the tag micro frontend order food. It starts with a constructor, and in the super, we call there, so we can use all the functionality from the HTML element. I also attach here a shadow DOM, that is a encapsulated view or DOM, which is attached to the web component. And this is a view where you can render something. I want to render my image and a name. So I do document create element image. So I create and instantiate an image element, HTML element, and I attach here my data name and data image to it, and I append it to the shadow DOM, which is my view. And how do I spin up this web component? At the bottom, you see that I do a custom elements define, and there I define finally my web component, and I give it a name with dashes, so I can use it this way. I've also here it running, so this what I showed you is works also. Okay, let's put pages together. Here you see an index HTML. It's nothing more than a very simple one. You see here my web component I showed you already with the name and the image, and you see that it is already rendering here. I do here at the end I load here a JavaScript, and it looks quite the same as what I showed you already. It's the micro frontend extends the HTML element. It has a shadow DOM, and okay, here I create the image and I render, or I attach it, the whole image to the shadow DOM, and you see that it works. Okay, that's already done. Here I have the rhino. He smells me, and I was climbing up on a tree. It was I was standing on a branch of more than 1.5 meter high, and it's a little bit yeah. I think the rhino is a little bit bigger than that, and he's smelling us. My friends are they climbed in another tree, or I was standing there on my own tree. On their own branch, sorry, and he was staring with his eyes. So I have a little question: how much does a rhino poop per day? 50 pounds, 100 pounds, or 200 pounds? Let me know. The food app, yes. A little bit back to the food app. Here you have the same food app, and you can also search for it, and also no problem, of course. Here, render it. You can choose some the price range, etc., etc. Choose one. And how do we make such a application? Also very, in a simple way. Here I show you, the simplified version of this application. I use one index HTML, and you see a orange arrow, and there I load 3 scripts, and these 3 scripts contain the browser bundle, the order bundle, and the profile example.com bundle, and these 3 contains 3 micro frontends. You can imagine which one, of course. My own micro frontend we have created just is inside the order example.com bundle, so we can use it here inside of it. What are you going to do here? Here on the top, you see that I use a div with an ID micro frontend root, and that's the place I want to render my micro frontend. And here the second arrow, I'm going to define here a lookup table, so you can select a micro frontend, and it depends on which route you choose. When you per default the browse restaurants will be shown with a slash, and when you use slash order foods in your URL, then the micro frontend order foods will be rendered. And at the third arrow, you see that I choose here. You can choose here the right web component, and you use here the window location path name that contains the route you type in. So now I've chosen my web component type, and let's instantiate it. Firstly, you see here that I do document get element by ID. That refers to the ID here at this place. This is the place where my micro frontend will be rendered. Here, then you see that I do a document to create element web component type, where I will instantiate the selected web component, and in the append child, it will be rendered. What are the advantages of runtime integration? Okay, you can develop, test, and deploy quite easily your micro frontend independently, and also with runtime integration, you have better integration between micro frontends because you can deep link and you have history, and and routing is also easier. That's also quite good. Which integration approach do you use? Here you see what when do you choose for one or the other. I start here with the first question: is your application big? When the answer is no, yeah, go with go for the micro frontend monolith. Sorry. And is your application yeah is big and your UI parts are strongly independent? Then you have to make the application with hyperlinks. And are the UI parts not strongly independent? Then you can choose for server-side integration when the server round trips are not a problem, or when it is a problem, performance problem, for example. Then you can choose for build time or runtime integration. You see the rhino, and he's sniffing and he's smelling me. And how does this end, this story? I don't know. He can run 55 kilometers an hour. That is approximately more than 40 miles. So don't run away. A component library in code. Yeah, you can also use component libraries, a UI component library I'm talking here about. Each microfrontend has its own UI component library, which contains input elements, bars, grids, everything you want to have in your front end standardized. And okay, when every microfront has its own UI component library, then there is not there can be a consistency problem in the styling and the colors, etc. But at the other end, when you choose for that, then yeah, then it is okay. You're not coupled together, so that is good. You can also choose for one UI component library, but then the disadvantage is that every microfront is coupled via the UI component library. But yeah, you have also you have the advantage that the styling, etc., is consistent. So you choose for one or the other. A component library, if you really need a component library, then build it framework agnostic. So you can better use USX or CSS modules or Stencil. You've heard of it. Communication between micro frontends. We have two tastes. Via the CustomEvent web API, which is standard. And you can also use shared state. You have the communication, the simple communication between micro frontend with CustomEvent. How can you do that? At the bottom, I use here a dispatch event. I send here a event from one micro frontend, and I can also define element at event listener in another micro frontend, and there I can catch the dispatched event. So in this way they can communicate with each other. You can also communicate with shared state. You can for shared state. You can also do that with Redux or Vux or GraphQL with Apollo. So every micro frontend can communicate with each other very easily, of course, with global state. But the disadvantage is that the micro frontends are coupled together. And this is a little bit the same story as with microservices, where you have one database. When you use one database for all those microservices, then they are also coupled together. So yeah, that's the question. Do you want global state, or do you want a separate state? And you can also use service workers. This will handle your caching of your application and also background syncing of your requests and posts. And this has the advantage that you can run your application offline. Here a little recap about microservices and micro frontends. You see 3 microservices. We split it up, our applications in verticals, they say user, order, catalog. And you see that every microservice registered themselves in the service registry. And they can discover each other via this registry. Each microservice has its own database. Each microservice communicates with each other with REST or messaging. You see also a API gateway. This is the same as our container application I was talking about. This API gateway does the cross-cutting concerns like authentication, authorization, monitoring, logging, routing your requests, and also decides also when and where something will be rendered in our micro frontend. You can also use GraphQL in the container application or your API gateway, so the client can choose what kind of response data it will receive from the backend. Here the Rhino is running, is charging me. Unbelievable. He smells me and was standing on the branch. I thought, shit, should I jump off or should I run away? I don't know. How to survive in charging Rhino? Move behind a tree to the blind side and then climb? Or what do you have to do? Run away? Do you have to make yourself big and make a lot of noise? Identify yourself as speaking in a calm, pleasing tone. Dive to the ground alive, feet first towards Rhino. What do you think? How do we, this is what the final thing I'm going to tell you. How do we speed up development? Nowadays, but also in the past, we work with specialized teams, every frontenders together, and business, etc., backenders together. Dus every skill is grouped, every team is grouped by skill. But you can also have teams which are cross-functional on the right-hand side, and the teams are grouped per use case, per customer needs. So this will, normally this can be can work faster. Development speed. How can you speed it up with more customer focus, so you can help the client build more feedback loops, more communication with the client, cross-functional teams. You can easily with micro frontends, you would easily in microservices also easily change your frameworks in your backend or front end. You have to split up your application in very little parts, so you have reduced scope, they say, so everything fits into the memory, so you can every application, front end and back end, it's very easily to understand and to maintain. So how this story ends, the Rhino was attacking me and he was standing before my tree, but a friend of mine was hanging in another tree, and he has a very old camera, and he didn't see that I was in danger. He was only focusing on the Rhino, and he zoomed in, and he makes such a lot of noise with his old camera that the Rhino ran away. So the world was green again for me. I survived it. I survived the monolith. Are there questions?